The proper training in bloodborne pathogens is important for the safety of employees in all work categories. The need for BBP training is essential for employees who are constantly at risk of exposure to blood, fluids, or other contaminated materials that are known to cause illnesses or even death. This training identifies the types of BBPs, BBP exposure, and the proper protection from exposure, how to dispose of contaminated or used materials, and what to do in the event of exposure. Bloodborne pathogens are microorganisms in human blood that can cause disease and are spread to humans once they come in contact with blood that contains the infected pathogen. Bloodborne pathogens such as HBV and HIV can be transmitted through contact with infected human blood and other potentially infectious body fluids such as semen, vaginal secretions, cerebrospinal fluid, amniotic fluid, and saliva. HBV and HIV are most commonly transmitted through sexual contact, sharing needles, contact between mucous membranes and infected body fluid, from mothers to her babies, accidental puncture from contaminated broken glass or other sharps. In laboratory situations, transmission is most likely to happen due to accidental jab from needles, broken glass, or other sharps that are infected and come in contact between broken or damaged skin. Intact skin is inaccessible against bloodborne pathogens. However, infected blood can enter the system through cuts, sores, acne and abrasions, sunburn, blisters, or any sort of broken or damaged skin. The mucous membrane is one of many ways that bloodborne pathogens may also be transported through the mouth, nose, or eyes. For example, a splash of infected blood to your mouth, nose, or eyes could result in a direct contact. Personal protective equipment is exceptionally important to use and practice at work to protect oneself from bloodborne pathogens. All blood and potentially infectious materials are treated as if they are, in fact, tainted, regardless of the perceived status of the individual. Just in case, whether or not you think the blood or body fluid is not tainted with bloodborne pathogens, you treat it as if it is. This is used in all situations, when and where exposure to blood or potentially tainted materials is possible. This also means work practices shall be used in situations where transmission may occur. In any given situation where there may be unprotected bloodborne pathogens, ensure you are wearing the correct personal protective equipment. For example, you may have noticed that healthcare professionals, including dental assistants, dentists, and others, always wear latex or protective gloves, a simple insurance they take to prevent blood or possibly contagious body fluids from coming in contact with skin. It is important to always have a boundary between employees and the contagious material. Use the personal protective equipment in unpredictable situations. Remove and discard PPE that is ripped, torn, or punctured or has no ability to function as a boundary to bloodborne pathogens. Take off the PPE before leaving the area. In an area that routinely has contagious material exposure to blood or potentially infectious materials, most importantly, PPE should be accessible. Infected clothing, gloves, PPE, or other contaminated materials must be placed in properly labeled bags or containers until ready to be disposed of, decontaminated, or laundered. It is important to find out where these bags or containers are located in your area. Gloves should be made of latex, nitrile, rubber, or other waterproof materials. It's important to prevent the risk of infection and contamination. OSHA recommends handling all blood and bodily fluids as if they have been infected. Employers should allow proper protective equipment such as gloves, gowns, goggles, face masks, and other equipment to prevent skin and mucous membrane exposure to infection. The employer should take steps to clean and launder gowns and gloves at no cost to the employee. The employee should make arrangements to repair or replace the equipment whenever needed. Hand washing is used to prevent transmission of bloodborne pathogens. Hands and other parts of skin should be washed as soon as possible following a contaminated incident. Use soft, antibacterial soap if possible. Avoid abrasive and harsh soaps that may open scabs or other sores. Hands must be washed promptly after removing the gloves or other PPE. Since hand washing is so essential, you must know where the location of the hand washing apparatus is nearest to the area. Sinks, restrooms, janitor closets, and so forth may be used for hand washing if supplied with soap. If you are in an area with no access to a sink, you may use an antiseptic cleanser with a clean cloth, paper towels, or antiseptic. When these methods are used, hands need to be washed with soap and water as soon as possible. Infectious materials, clothing, or solutions soiled with blood or body fluids ought to be put in correct containers or bags. You should wear gloves when touching clothes that are visibly infected with blood. Warning labels must be attached to containers that are used specifically for waste, refrigerators, and freezers containing blood or other infectious material, and other containers used to store, transport, or ship blood or other infectious materials. These labels are fluorescent orange, red, or orange red, and they are available from EHS. Bags used to dispose of regulated waste must be red or orange red, and they too must have the biohazard symbol readily visible upon them. Regulated waste should be double bagged to guard against the possibility of leakage if the first bag is punctured. When assigned with tasks that require needle handling along with some other sharps-related objects, you must complete these tasks with caution. Needles and sharps must be disposed of very carefully and within a puncture-resistant container. You should never bend, break, or recap fine needles and sharps-related objects. Housekeepers, custodians, and others can be punctured or cut by improperly disposed of needles and broken glass. Needles must be disposed of in a labeled sharps container only. When containers that are used for sharps are being moved from an area of use, the containers must be closed immediately prior to replacement in order to prevent spillage or puncture of needles during transport or handling of used needles. Broken glass that has been visibly infected with blood must be cleaned with a disinfectant solution before it is disturbed or removed. Glass that has been sterilized may be placed in a sharps container that has a lid and is puncture-proof, leak-proof on all sides and bottom, and has appropriate labels. Broken glass should never be directly picked up with your hands. You should sweep or brush the infectious material into a dustpan and place it into a biohazard container or a bag that is marked. Broken, non-infected glass may be placed in a closable puncture-resistant container such as a cardboard box or coffee can. Bloodborne transmission can occur when an employee touches an infected individual's cut, open sore, broken or damaged skin. If any employee has been exposed to blood or bodily fluid, the employer should take steps to arrange for a medical evaluation immediately. If there is a risk that the employee can be infected with the virus, medications should be provided. Follow-ups are essential to confirm whether or not the employee has developed any protective antibodies. Employers need to maintain records of work-related injuries and illnesses. They should report job-related deaths or hospitalization of more than 3 employees in one incident to the nearest OSHA office. The employer should determine the work opportunities where all employees have an occupational exposure and occupation classifications where some employees are exposed to pathogens based on the allocation of certain responsibilities, such as protection for the employees who will be exposed the most. The Health Insurance Portability and Accountability Act, or HIPAA, privacy rule requires covered entities to maintain employee exposure records. In today's environment, which is filled with health issues and infectious diseases, it is important to learn potential hazards presented by bloodborne pathogens. We know that bloodborne pathogens like HIV, human immunodeficiency viral, are transmitted from an infected person to a healthy person through blood or mucus. Exposure to infected blood components can also increase the risk of creating a disease. The employer should review the rules and standards of OSHA on a yearly basis and make sufficient changes in its policies and practices to make sure that employees are well protected with low risk of exposure to bloodborne pathogens. The employer should take some engineering and work practice controls in situations where exposure to harmful bloodborne pathogens may occur. If you are exposed to blood or potentially infectious materials on the job, you may request a hepatitis B vaccination. If the vaccine is administered immediately after exposure, it is extremely effective at preventing the disease. The hepatitis B vaccination is given in a series of 3 shots. The second shot is given 1 month after the first, and the third shot follows 5 months after the second. This series gradually builds up the body's immunity to the hepatitis B virus. The vaccine itself is made from yeast cultures. There is no danger of contracting the disease from getting the shots, and once vaccinated, a person does not need to receive the series again. There are booster shots available, however, and in some instances, these may be recommended. These boosters are utilized if there is an outbreak of hepatitis B at a particular location. If your primary job involves coming in contact with the hepatitis B virus, you should receive the vaccination. It will help reduce the risk of infection significantly. If this is the case, your employer should provide the hepatitis B vaccination to employees at no cost. Okay, let's see what you've retained. Washing your hands with soap and water for 15 to 20 seconds can help with maximum protection from the infection. True or false? The answer is false. Hand washing is used to prevent transmission of bloodborne pathogens. Hands and other parts of skin should be washed meticulously and as soon as possible following a contaminated incident. Soft, antibacterial soap should be used. Try to avoid abrasive and harsh soaps that may open scabs or other sores. Hands also need to be washed promptly after removing gloves or other PPE. Let's see if you remember this. If you are exposed to potentially infectious materials on the job, you may request a vaccine for which of the following bloodborne diseases? A. HIV. B. Syphilis. C. Hepatitis. D. Brucellosis. The correct answer is C. If your primary job involves coming in contact with a hepatitis B virus, you should receive the vaccination. By receiving the hepatitis B vaccine, you significantly reduce your risk of infection. All right, here's another one. Which of the following could contain bloodborne pathogens? A. Saliva. B. Semen. C. Amniotic fluid. Or D. All of the above. The correct answer is D. Bloodborne pathogens such as HBV and HIV can be transmitted through contact with infected human blood and other potentially infectious body fluids such as saliva, semen, amniotic fluid, vaginal secretions, and cerebrospinal fluid. Bloodborne pathogens are microorganisms in human blood that can cause disease and are spread to humans once they come in contact with blood that contains the infected pathogen. It's important to know ways in which infections can lead to exposure and transmit it, and ways to prevent exposure through personal protective equipment and vaccinations. Employers are responsible for training employees on this subject matter in an effort to reduce bloodborne pathogen-related incidents. There are two primary hazards associated with flammable and combustible liquids: explosion and fire. In order to prevent these hazards, the National Fire Protection Association's publication NFPA 30 Flammable and Combustible Liquids Code was created. 29 CFR 1910.106 applies to the handling, storage, and use of flammable and combustible liquids with a flash point below 200 degrees Fahrenheit. This standard addresses the primary concerns of design and construction, ventilation, ignition, sources, and storage. There are a number of definitions included in 29 CFR 1910.106. These definitions were derived from consensus standards and were not uniquely developed for OSHA standards. Aerosol is a material which is dispensed from its container as a mist, spray, or foam by a propellant under pressure. Boiling point is the boiling point of a liquid at a pressure of 14.7 pounds per square inch absolute. This pressure is equivalent to 760 millimeters of mercury. At temperatures above the boiling point, the pressure of the atmosphere can no longer hold the liquid in the liquid state, and bubbles begin to form. The lower the boiling point, the greater the vapor pressure at normal ambient temperatures, and consequently, the greater the fire risk. A container is any can, barrel, or drum. A closed container is a container sealed by means of a lid or other device so that neither liquid nor vapor will escape from it at ordinary temperatures. A fire area is an area of a building separated from the remainder of the building by construction having a fire resistance of at least 1 hour and having all communicating openings properly protected by an assembly having a fire resistance rating of at least 1 hour. A flash point is the minimum temperature at which a liquid gives off vapor within a test vessel in sufficient concentration to form an ignitable mixture with air near the surface of the liquid. The flash point is normally an indication of susceptibility to ignition. The flash point is determined by heating the liquid in test equipment and measuring the temperature at which a flash will be obtained when a small flame is introduced in the vapor zone above the surface of the liquid. A standard closed container is used to determine the closed cup flash point and a standard open surface dish for the open cup flash point temperature, as specified by the American Society for Testing and Materials. These methods are referred in OSHA's 1910-106 standard. A combustible liquid is any liquid having a flash point at or above 100 degrees Fahrenheit. Combustible liquids are divided into two classes. Class 2 liquids include those with flash points at or above 100 degrees Fahrenheit and below 140 degrees Fahrenheit, except any mixture having components with flash points of 200 degrees Fahrenheit or higher, the volume of which make up 99% or more of the total volume of the mixture. Class 3 liquids include those with flash points at or above 140 degrees Fahrenheit. Class 3 liquids are subdivided into two subclasses. Class 3A liquids include those with flash points at or above 140 degrees Fahrenheit and below 200 degrees Fahrenheit, except any mixture having components with flash points of 200 degrees Fahrenheit or higher, the total volume of which make up 99% or more of the total volume of the mixture. Class 3B liquids include those with flash points at or above 200 degrees Fahrenheit. This section does not regulate Class 3B liquids. When a combustible liquid is heated within 30 degrees Fahrenheit of its flash point, it must be handled in accordance with the requirements for the next lower class of liquids. A flammable liquid is any liquid having a flash point below 100 degrees Fahrenheit, except any mixture having components with flash points of 100 degrees Fahrenheit or higher, the total of which make up 99% or more of the total volume of the mixture. Flammable liquids are known as Class 1 liquids. Class 1 liquids are divided into three classes. Class 1A includes liquids having flash points below 73 degrees Fahrenheit and having a boiling point below 100 degrees Fahrenheit. Class 1B includes liquids having flash points below 73 degrees Fahrenheit and having a boiling point at or above 100 degrees Fahrenheit. Class 1C includes liquids having flash points at or above 73 degrees Fahrenheit and below 100 degrees Fahrenheit. Flashpoint was selected as the basis for classification of flammable and combustible liquids because it is directly related to a liquid's ability to generate vapor, i.e., volatility. Since it is the vapor of the liquid, not the liquid itself that burns, vapor generation becomes the primary factor in determining the fire hazard. The expression low flash, high hazard applies. Liquids having flashpoints below ambient storage temperatures generally display a rapid rate of flame spread over the surface of the liquid, since it is not necessary for the heat of the fire to expend its energy in heating the liquid to generate more vapor. When vapors of a flammable or combustible liquid are mixed with air in the proper proportions in the presence of a source of ignition, rapid combustion, or an explosion can occur. The proper proportion is called the flammable range and is also often referred to as the explosive range. The flammable range includes all concentrations of flammable vapor or gas in air in which a flash will occur or a flame will travel if the mixture is ignited. There is a minimum concentration of vapor or gas in air below which propagation of flame does not occur or contact with a source of ignition. There is also a maximum proportion of vapor in the air above which propagation of flame does not occur. These boundary line mixtures of vapor with air are known as the lower and upper flammable limits, respectively, and they are usually expressed in terms of percentage by volume of vapor in the air. In popular jargon, a vapor-air mixture below the lower flammable limit is too lean to burn or explode, and a mixture above the upper flammable limit is too rich to burn or explode. The LFL is also known as the lower explosive limit. The UFL is also referred to as the upper explosive limit, or UEL. There is no differentiation between the terms flammable and explosive as applied to the lower and upper limits of flammability. Only approved containers and portable tanks may be used to store flammable and combustible liquids. Metal containers and portable tanks meeting the requirements of the Department of Transportation, DOT, 49 CFR 178 are deemed acceptable when containing products that are authorized by the DOT. 29 CFR 1910-106 also requires portable tanks to have provision for emergency venting. Top-mounted emergency vents must be capable of limiting internal pressure under fire exposure conditions to 10 psig or 30% of the bursting pressure of the tank, whichever is greater. Portable tanks are also required to have at least one pressure-activated vent with a minimum capacity of 6,000 cubic feet of free air at 14.7 psia and 60 degrees Fahrenheit. These vents must be set to open at not less than 5 psig. If fusible vents are used, they must be actuated by elements that operate at temperature not exceeding 300 degrees Fahrenheit. Maximum allowable sizes of various types of containers and portable tanks are specified based on the class of flammable and combustible liquid they contain. No more than 60 gallons of Class 1 and or Class 2 liquids, or no more than 120 gallons of Class 3 liquids may be stored in an individual cabinet. This standard permits both metal and wooden storage cabinets. Storage cabinets must be designed and constructed to limit the internal temperature to no more than 325 degrees Fahrenheit when subjected to a standardized 10-minute fire test. All joints and seams must remain tight and the door securely closed during the fire test. Storage cabinets have to be conspicuously labeled flammable, keep fire away. The bottom, top, door, and sides of metal cabinets need to be at least number 18 gauge sheet metal and double-walled with 1.5-inch airspace. The door must be provided with a 3-point lock and the door sill must be raised at least 2 inches above the bottom of the cabinet. The design and construction of inside storage rooms are to comply with the test specifications included in NFPA 251-1969, Standard Methods of Fire Tests of Building Construction and Materials. Openings to other rooms or buildings must be provided with non-combustible liquid tight-raised sills or ramps at least 4 inches in height, or the floor in the storage area must be at least 4 inches below the surrounding floor. Openings must be provided with approved self-closing fire doors. The room must be liquid-tight in which the walls join the floor. A permissible alternative to the sill or ramp is an open graded trench inside of the room which drains to a safe location. This method may be preferred if there is an extensive need to transfer flammable liquids into and out of the room by means of hand trucks. The size of storage within inside storage rooms should comply with the following. Electrical wiring and equipment located within inside storage rooms used to Class 1 liquids must be approved under Subpart S. Electrical for Class 1, Division 2, hazardous locations for Class 2 and Class 3 liquids must be approved for general use. Every inside storage room must be provided with either a gravity or a mechanical exhaust ventilation system designed to provide a complete change of air within the room at least 6 times per hour. Ventilation is vital to the prevention of flammable liquid fires and explosions. It is important to ensure that airflow through the system is constant and prevents the accumulation of any flammable vapors. In every inside storage room, there must contain a maintained aisle at least 3 feet wide. Easy movement within the room is necessary in order to reduce the potential for spilling or damaging the containers and to provide both access for firefighting and a ready escape path for occupants of the room should a fire occur. Containers over 30-gallon capacity must not be stacked one upon the other. Such containers are built to DOT specifications and are not required to withstand a drop test greater than 3 feet when full. Dispensing must be performed only by approved pump or self-closing faucet. Flammable or combustible liquids, including stock for sale, must not be stored so as to limit use of exits, stairways, or areas normally used for the safe egress of people. Storage must be prohibited except for which is required for maintenance and operation of equipment. Such storage must be kept in closed metal containers stored in a storage cabinet or in safety cans or in an inside storage room not having a door that opens into a portion of the building used by the public. Storage of incompatible materials that create a fire exposure oxidizers, water-reactive chemicals, certain acids, and other chemicals is not permitted. The last type of inside storage includes storage within warehouses or storage buildings. These structures are sometimes referred to as outside storage rooms. Practically, any quantity of flammable and combustible liquid can be stored in these buildings, provided that they are stored in configuration consistent with the tables in this paragraph. Containers and piles must be separated by pallets or dunnage where necessary to provide stability and to prevent excessive stress on container walls. Stored material must not be piled within 3 feet of beams or girders and be at least 3 feet below sprinkler deflectors or discharge orifices of water spray or other fire protection equipment. Aisles of at least 3 feet in width must be maintained to access doors, windows, or standpipe connections. Associated requirements are given for storage adjacent to buildings. Also included are requirements involving controls for diversion of spills away from buildings and security measures for protection against trespassing and tampering. Certain housekeeping requirements are given which relate to control of weeds, debris, and accumulation of unnecessary combustibles. Suitable fire control devices, such as small hose or portable fire extinguishers, must be available at locations where flammable or combustible liquids are stored. At least one portable fire extinguisher having a rating of not less than 12B units must be located outside of, but not more than 10 feet from the door opening into any room used for storage, and not less than 10 feet, nor more than 25 feet from any Class 1 or Class 2 liquid storage area located outside of a storage room, but not inside a building. The reason for requiring that portable fire extinguishers be located a distance away from the storage room is that fires involving Class 1 and Class 2 flammable liquids are likely to escalate rapidly. If the fire extinguisher is too close to the storage area, it may be impossible to get to it once the fire has started. Open flames and smoking is not permitted in flammable or combustible liquid storage areas. Materials which react with water must not be stored in the same room with flammable or combustible liquids. Many flammable and combustible liquid storage areas are protected by automatic sprinkler or water spray systems and hose lines. Consequently, any storage of water-reactive material in the storage area creates an unreasonable risk. Incidental storage or use of flammable or combustible liquids includes portions of an industrial plant where the use and handling of flammable or combustible liquids is only incidental to the principal business, such as paint thinner storage in an automobile assembly plant, solvents used in the construction of electronic equipment, and flammable finishing materials used in furniture manufacturing. Flammable or combustible liquids must be stored in tanks or closed containers. The quantity of liquid that may be located outside of an inside storage room or storage cabinet in a building or in any one fire area of a building must not exceed 25 gallons of Class 1A liquids in containers, 120 gallons of Class 1B, 1C, 2, or 3 liquids in containers, 660 gallons of Class 1B, C, 2, or 3 liquids in a single portable tank. Flammable liquids must be kept in covered containers when not actually in use. Where flammable or combustible liquids are used or handled, except in closed containers, means must be provided to dispose promptly and safely of leakage or spills. Flammable or combustible liquids must be drawn from or transferred into vessels, containers, or portable tanks within a building only in the following manner. 1. Through a closed piping system. 2. From safety cans. 3. By means of a device drawing through the top. Or 4. From containers or portable tanks by gravity through an approved self-closing valve. Transfer operations must be provided with adequate ventilation. Sources of ignition are not permitted in areas where flammable vapors may travel. There are two primary hazards associated with flammable and combustible liquids: explosion and fire. These standards were placed in order to prevent these hazards so that it is recognized and would be addressed. The primary concerns are design and construction, ventilation, ignition sources, and storage. Learning the boiling points and understanding the degrees in which explosions can occur and how to prevent them is key. Where applicable, employers are responsible in training of employees on this subject matter in an effort to reduce incidents.